Okay.
Yo estoy mirando ahí arriba. Okay. Hello everyone.
Okay. Okay.
Yo estoy mirando ahí arriba. Since we have like a
Bit of a
something like a mini
feedback loop.
delay or something like that. But
Yeah.
whatever.
Cool.
So we're going to wait like 2 or 3 minutes for everyone else to join, and then we start with this crystal Q&A live whatever thingy.
We need like a screen like starting in and but for the next one.
Yeah, we have a working hangout session that's enough for this time.
Yeah, that's better than the last time.
3 a.m. in Istanbul. Sardar, you're a crazy man.
Great white.
Yeah. I didn't take it off since the last time. in
Yeah,
San
you
Francisco.
can totally tell.
Problem was the last time you didn't have enough experts in the room. Right.
Okay, so it's 9 o'clock.
Yeah.
We can get started.
Yeah.
Okay. Well, yeah. Okay, so tonight we are tonight here in Buenos Aires. I am Brian. Here is Matias, Martin, and Gustavo. The people who went to the code camp knows Gustavo from there. And well, we have been collecting questions since the code camp and since then. And well, we will try to answer them and follow the stream of chat in the Hangout in the YouTube. So if there's any new question, we can include them. But well, mostly many of the questions are around the optimizations of the compiler and Windows support. Those are like kind of the main topics, so we will go around them. And we'll try to, on some questions, we'll try to discuss the work we have been doing on the last weeks that maybe is not so visible in the repository because there's a lot of goes in discussions and ideas going back and forth.
Whiteboard there.
Yeah, the whiteboard and all those. Well, one of the questions was, the first one was, which makes to Crystal faster than Node.js? And actually, I'm not sure we claim that we're faster than Node.js.
Yeah, I don't think so.
But we're, everybody knows we are pretty happy with the efficiency the language has on runtime. The reason for that is because on our core we stand up over LLVM. We do incredible optimizations, and the generator code is bare metal on Osmos assembly, and over that we have a great deal on how things are represented in memory and how the dispatch of the methods are done to reduce as much as possible all the overhead. Yeah, and then the well, with the standard libraries, all the fevers and the schedulers try to reduce, try to use as much CPU as they can when they are waiting for I/O. So that's together make us really fast.
The streaming part of the standard library is quite important, because that way you avoid unnecessary copies of information coming from the network and into other applications or other parts of your application. So that I think plays a major role in improving performance.
Yeah, the first part where you see that is when generating the string representation of the objects. You receive the I/O when you want to stream that content, and that avoids intermediate strings, and that's helped for in lots of cases. So that is most of it is a design of the standard library, and that's impact really positive on the performance.
Yeah, that way you also alleviate some of the GC pressure. And well, what we can say is that Node doesn't do the same, because actually I don't know. So that, again, we don't claim to be faster than Node.js. We're just happy with our current performance.
I'm sure we are faster in some benchmarks.
Yeah, and slower in others.
Yeah, so to answer that question would require more context, more concrete cases, I think.
Yeah, and also, I don't know, I think we as a team do not dwell too much on benchmarks and all that kind of stuff, because it's really not very productive for the design of for the development of the design of the language. So
yep. Yeah, no, all the benchmarks are sometimes some specific situation, and it's hard to have a,
like, we don't want to optimize specifically for some benchmarks, because that usually leads to a worse design, or may lead to a worse design than otherwise.
Okay. Let's go to the next question. The first in the Windows topic. How much more work do we need to get done for Windows support to land? A lot.
Yeah.
But there was a really good day today for the Windows in the language. We're aiming to on this week to have some initial merges for supporting linking and compiling in Windows. And actually, one of the contributors did a good PR that we will be probably accepting.
Yeah, kudos to Chris Hobbs. Amazing work.
Yeah, yeah, and there is a long pull request from Guilherme. It's hard to pronounce the GitHub handlers. It doesn't have enough vowels. And from that PR, we will start. The idea is to refactor that in a way that blends naturally with the standard library, and with some of the new abstractions that are starting to appear in the repository for like isolating the platform-specific stuff. So we in that PR, there is a lot of knowledge of how to do things in Windows, and we want to analyze that and start moving together in a inappropriate crystal system namespace, and hide there all the POSIX versus Windows implementations. Maybe one of the first things that we need to tackle is how to abstract the file handlers that are quite different from one to the other. Although we have the implementation for Windows, we need to abstract that in a nice way. So that's more about code organization. We need to do that, and for sure start testing on Windows how everything will be linked, and first with small programs and then eventually with the compiler itself. And today we release some of the binaries, some of the libraries that are needed for eventually compiling all the standard library or part of the standard library on Windows. So we are start leaving copies of them for downloading and distributing eventually the compiler, or at least to facilitate the development of the Windows support. What else are you missing?
Yeah, like I think probably the most work will be concentrated on re-implementing some of the subsystems in which POSIX is different than the Windows story, because both for file handling and I/O and threading, yeah, well, I think those are basically the big three areas in which we might be able to use POSIX compatible libraries in Windows, but we want to be very native in Windows. So
yeah, we want to target the Microsoft native platform. We don't want to use Swing or Wine for supporting. Eventually, that might come, but the idea of supporting Windows is to go native first, and then we'll see what else we can do. And maybe at the beginning, the CI on Windows will come later. Maybe the initial support. We don't want to hold the integration of Windows until the very end, because that makes harder to merge. So we want to start merging piece by piece functionalities to start supporting each time bigger part of the standard library until we reach the whole, and then it makes sense to have a CI for that. So that's more or less the roadmap that should happen, and it will take some time, but we are pretty happy to accept small contributions as long as it start like hiding the platform specific in this namespace. So there are recent conversation of how to do that. So that's the roadmap and how the effort should go. And the next question was, what versions of Windows will support? And I don't know. First, Windows 10.
We want to Windows 10 first, and then we'll see from there.
Which is the VM that you can get, and we are trying to use the command line tools, the C++ command line tools that ship Microsoft, which is really small comparing to the either version of the Visual Studio. So we're using that for developing. The tricky one, how about, will it have the same performance as in Linux and Mac, the Windows version?
We hope so. We certainly hope so.
Yeah, we hope so. First, we need to see how the I/O handles. In the pull request done by Guilherme, he re-implemented the scheduler. So we need to. I didn't compare them, so I'm not sure if it is a naive implementation or not. First, we need to have it work, and then we can optimize from there.
Yeah, there's also a chicken and egg situation here, where once we can provide some basic support for Windows, we expect to get more contributors that specialize in the system.
Yeah,
and we hope to get lots of PRs with optimizations. Targeting Windows specifically, but until we do that, maybe there's a lot of people who's holding from adopting Crystal or trying out Crystal because it's not in their favorite platform, and they don't trust us to do that. So that's what we want to get out of the way first.
Yeah, it's really great when some contributors shows like good proficiency in Windows development, because it's been like a decade since I developed in Windows.
Yeah.
And
for me too.
It's a blessing.
It's a blessing. Yeah, it's really great. So it's hard to tell which how will be the performance. We aim to have a good performance. We don't only want to have development and then don't use it for real. But also with new platform, it will happen that there will come a lot of bugs.
Yeah.
And for that also, support will be needed on both from our side and for the community, because otherwise we are getting more platforms and not being able to handle a lot of support. Okay.
Yeah.
So how much Crystal code is lacking in documentation? That's
the next question.
The next question. In terms of API documentation, I don't think we are too bad there. I think the coverage overall is pretty good. We generally try to document every new method that we introduce into the STD lib, and also to ask contributors to add documentation in the PRs.
So at least we are not making it worse.
Yeah, yeah. And also there's a decent language reference to consult, where we think there's a big gap right now is in a sort of more
the boarding or this whole story.
More elaborated materials
like user guide type documentation or
like
cookbooks and
I begin with a use case. So how do I set up a server that will query a relational database and respond with some JSON serialized thing? Sort of the whole story with some narrative that will help beginners and people who are not aware of all the little pieces that you need to place together to make it work.
Like how you make a command line tools, or how you make a small graphic applications, maybe. But with Binding, the answer is that there is a possibility to do all those kind of applications with Crystal, but there is not a guide that someone could search, I want to make this, and kind of follow some initial
recipes in a way, right?
Yeah. Also, we know there are some blind spots in the documentation. During the code camp, we found out that some of the top-level functions or Mac and macros, are either not documented or hard to find in the documentation. So we are also aware of that. But I think for the most part, most methods and classes are documented. So.
Yeah, there was a discussion about how to group by topics certain functions, or like all the concurrency, not only group them by namespace, but because nowadays are in the top level and they are hard to find. Okay.
Next one is, could you use your own documentation page instead of Gitbook? I'm not sure I understand where this question goes. The language reference is Gitbook. I think it does a pretty good job for that. Then the API docs are custom. They are a tool that's embedded in the compiler. So that's already custom. We can, we can analyze PRs or whatever design suggestions that you may have.
There are a couple of things we actually want to do with that, like being able to improve the search, and there are a couple of things we know we have to tackle at some time, but it's ironically it's not a Gitbook problem. Like it's by not using Gitbook, we have lost that searchability, whatever. For the language reference, I think if we see any superior proposal, we might go with that. But I think it would be more useful for us to know why do you think like we should drop Gitbook, because it just works.
Yeah, and maybe what's, I mean, that's a bit scattered. Even if there's like the links for the API reference and the language reference are reachable from the website, maybe we could try to start a documentation section where we can also start gathering and collecting these tutorials that we mentioned in the previous question. So that would make a nice bundle all together.
Yeah. Okay. But by the way, the last 4 or 5 questions were made by Faustino Aguilar, which I think is in the chat. And the first one, the one regarding Node.js, was made by Juan Varela, which I don't know if he's in chat. Okay.
Thank you for the question.
Yeah.
And I see Faustino is making even more questions at the very end.
Yeah.
Okay. Then we have another question is regarding what plans does the Crystal team have to decrease the latency of reviewing and merging PRs? Our plans is to get as much as support that we can have, so we can dedicate even more time. That's the bottom line. Like during Manas, we have like we have a lot of, we dedicate time, but there is an upper bound of what we can do here. Usually the support is currently 20% of what we are doing. Just to measure how much Manas is being able to put on Crystal since the beginning, actually, during the last everything.
5-6 years.
5-6 years. No. So sometimes there are months where we can dedicate more. Sometimes it might seem that there are less dedication, but maybe it's because also there's other kind of work that pull us out from the repository. That's discussing ideas and trying things, and sometimes they are like halfway. Yeah, that whiteboard. So those are some of the challenges. Just some of the things that we need to allocate our time and effort.
Yeah, and there's some variability also, because there's some time that comes from our own personal slots and the energy. It cycles, and sometimes you are super excited and can't think of anything else than Crystal. Other times you want to visit your
family,
or go and go to go have a life, go to the park, whatever.
We don't only develop Crystal here. We also do it on our spare time, on our 2 a.m. in the morning, for example. We need to share that, and also sometimes we need to focus on some tasks that are like we need to divide between the things the community want and the things that we need to get done, and that is quite challenging. There was one talk from Ivan from Elm, which is pretty enlightening regarding all the things that are around designing a language and trying to hold a community. That is named "Code is the easy part," and in the repository, the thing that is there is the code. And we can, there is a lot of discussions to be made on top of that, but then there is how to keep the community working. And so it's not only about, the PRs are part of the community, but coding is not just the part. It's not about like, okay, I have done this PR, like, why is not accepted? Like, answer is, I need to change something or not. Maybe we need to discuss it or think if it's the right way, even if it's for the short term, it seems to. So watch the code is the easy part. Definitely, it's a nice talk from Ivan.
Yeah, we're always trying to learn from other bigger and more mature communities. One is Elm. The other one we look up to a lot is Rust. They are doing such an amazing job at collaborating with the community, and they have a huge community, so that they have proved it. They know how to make it work. But yeah, even learning from that and applying the practices takes some time. So the bottom line is we are trying to learn and get better at that.
Yeah. We know that we need to always offer a little bit of like expose what we are working off, because otherwise they think that we are not working on Crystal, and it's hard for that to happen. Like you have this idea on your brain that is always puzzling, and you wake up and say, yeah, I need to do that. And yeah.
It's also the first language we design, so. That's a big point.
In college, I had design languages, but they were toy.
Okay.
But you didn't have a community.
No.
That's the thing we are getting used to and learning and trying to do our best. And well, we may not be always doing the ideal perfect way, but we are trying to. That's something we know for sure. And well, we have like ups and downs, and I think one of the benefits of one of the drawbacks of having a successful project or a community growing is that you have to keep the community going and all of that. But that's also the main advantage, that whenever you grow a community, you start having more people coming in and you eventually have more people from the community you can trust enough to get them, I don't know, handle the PRs and whatever, like share all the work and not depend on the 5-10 people here at Manas working on this. Like it's part of a two-sided story, and well, we are getting there. I think we are getting there. So sorry about the.
Yeah, please be patient with us.
Yeah, we are humans also.
Yeah, by the way, that question was from Chris. Yeah. Chris Hobbs.
Yeah. And thanks, Chris, for all the work. Seriously,
yeah,
it's like
for sure. Yeah,
definitely. Okay, so next question is a parser one. Is there any plan to use LALR1 parser for the compiler? I think it's LLN parser now, and I can't find a full grammar like this. Some link in Markdown.
This question is from Seal Wu.
Seal Wu.
Yeah.
Okay.
I hope I didn't murder your name. Sorry.
So there is no formal description of the grammar because because we didn't do it. We based initially on Ruby grammar, and we use those rules for a lot of things. There are some small variation because we have different keywords, but more or less is the same idea. And the parser is written by hand in Crystal because At the beginning, there was no parser generator. I think there is one or two already, but by writing the parser by hand, we are able to do it as fast as possible. There are maybe more bugs than if you will use a tool, for sure, but the parser needs to be really performant. So that's why it's written by hand, and that's why we don't have a formal definition, because we didn't need it.
One drawback is that we lose some automated tools for editor support.
Yeah, there are. We would love to have some formal definition of the language, not only of the syntaxes, but also of the semantic. But things the language is also changing a little bit every now and then. Not so much, but there are some changes. Well, it's still being discovered, like some part of the language. The core are already there, so we could start like formalizing that in some documents. But that will reduce the effort on moving the language forward also.
Yeah, that's always the question. But I think writing a more formal or formalish specification could actually help move faster, because once you have like that document you can refer to it, it's much easier to decide if something is a bug or not. Right now it's super on a case by case basis, and you try to just sort of use your taste.
Like during this week or last week was like if we can return from an ensure or not. Like we didn't design that, and we are designing right now like what we want to do on that situation.
What I think definitely won't happen, at least in the near future, is deriving the parser from a formal specification. I think we are very happy with the hand roll and
the implementation won't change. It isn't likely to change.
Okay, next question is, do you know what compilation speeds are likely achievable with incremental compilation in non-release mode? I think you've been
that's kind of the whiteboard actually. Don't look at it.
This question is from Martin Yago, I think.
Okay, so one of the concerns of the current compiler are both that we want to make it faster and we want to make it lighter in memory footprint during the compilation. Every now and then there is an issue like I have like a shit ton of gigabytes of RAM and I can't compile the compiler. We are aware of that. There are different things that we want to try. Some of them are incremental compilation. Some there are just technique to organize things a little bit different. So I can like describe kind of quickly, more or less, which are the attempts that we have tried or we have been thinking and we will be trying in the near future. The first was like there is a pull request that introduced thin LTO. That is something that LLVM comes with an incremental compilation with a cache for not building, not compiling again and linking on intermediate things. It was a nice shot, but it only worked for release because on non-release compilation, it wasn't an improvement. But it's something that it might get introduced eventually. It was just an experiment if LLVM solves everything once again. Another technique to improve the compiler is actually to reduce the memory footprint. Is that right now all the LLVM modules that is one per class they are emitted all together or interleaved based on the call graph. If we emit the LLVM modules in a lexicographical order, we will be able to allocate memory on for one or n LLVM modules at a time, and then deallocate that, and then the other. We still need to profile if that's the play with it and profile it if that's the bottleneck. But that's one of the ideas, to reduce how many open resources we have with the LLVM at the time. And then one other like dream that we have from the very long past is to have like actual incremental compilation that might come together with some sort of daemon compiler that will watch on changes for certain sources of files and compile just those. Maybe that requires files watchers. That will require reopening LLVM modules in bit codes to reopen and just replace some functions and ensure that everything makes sense, and then compiling only those and linking all together. It's hard to tell with all those pieces.
Which is the winner?
Which is the winner? Yeah, and in this technique, there are a lot of new pieces, like a persistable cache or something in memory to hold all intermediate results, how to analyze it, how the changes broadcast to the compiler, because right now the compiler parse all the files and analyze it all at the same time. If we want to only process one change on some files, there are a lot of things that need to be changed. But and that is for incremental compilation. But the whole process still, the first one will still be heavy. So there will be a combination with the other techniques to be able to improve the whole experience.
Yeah, the interesting thing is that we just began to scratch the surface of that. We never thought of doing that before, and there's a lot of things to try still.
Currently, the bigger Crystal program is the Crystal compiler. So we are the first one that we are struggling with that. Every change you make to the compiler, it took more than we would like to. But well, and one of the last technique was to improve, like formalize a bit more how we analyze and do the type inference in a method, and get as much information as we can for just the definition, despite the class where it is, or the location, or the files, and persist some part of the analysis that will allow us to do in a modular way all the type inference and semantic phases. That will also need some cache for files or for changing depths in files. More or less, those are the strategies that we are trying to do. But it's hard to know right now how good it will get. But we have these ideas, and we are always like trying to get new ideas. We are not close on what to try to get the compiler faster. Yeah, those are more or less the ideas.
Okay. The next question is, I know it's hard, but Swift has a REPL. I have no idea how they do it, but do you think it'd be possible also for Crystal? This is a question from Will Lane Weber.
From Will.
Will. Yeah, Will. Yeah, I think we skimmed over Swift's implementation, and they do some sort of trickery that, like, they take previous declarations and they import those in new code as external declarations, and they JIT compile new code as it comes from the REPL. Probably that's kind of hard to do for Crystal, because if you introduce a new type in a variable or something like that, you would need to generate a new method for an existing class, and then keep track of that and do not compile it again. And also the variable names we can reuse and change type dynamically during the execution. Well, I mean that the type changes during the execution, which you cannot do in Swift. So I don't know. I think it might be possible, but very hard to do. So yeah,
Pierre's welcome.
Yeah, Pierre's welcome. There is some
Rebels welcome.
Yeah, there is some sort of a pseudo REPL that someone did, but I think it basically recompiles everything
and re-execute it. Yeah. The thing is how to keep the values, how to migrate the value from the previous session to the new one.
And side effects, right?
Yeah, and it was so fun to have the playground made. No, seriously, if we have a REPL, we will use it. But
yeah,
the playground was enough at that time, although we have some limitations.
I think there are some language design decisions that affect both this particular problem, i.e. building a REPL, and incremental compilation as well. Like, for example, in Crystal, you can reopen classes. So that introduces a whole lot of problems that make building a REPL and doing incremental compilation very difficult. So
yeah, and the fact that the available implementations of a method are affected by who calls them.
Yeah,
that's also
okay. I think the next one is also yours.
Okay, next one is dynamic dispatch, for example, with vtables supposed to be part of the language, and is it planned for 1.0, and if not, would a PR be accepted? Well,
this is from
Aurelien
Bidon.
Aurelien Bidon. Okay, the language already has some sort of kind of dynamic dispatch. We call it, I don't know if it's a formal name or what, runtime dispatch, which is basically the compiler knows at compile time on which types it needs to dispatch. So the compiler knows upfront which methods it should call. So it doesn't need a vtable. Introducing a vtable is more like it's a more open system, because basically you could compile a class and then introduce a new subclass which just writes a new entry in that vtable and call it from existing client code that doesn't know about the new subclass. Well, you cannot do that in Crystal due to the language design. But also introducing the vtable, it introduces this sort of indirection which it might or may not affect performance, and also maybe object size, because by having a vtable, you need to keep a pointer to the vtable in each of the objects of that particular class. So, I mean, Crystal doesn't have vtables and dynamic dispatch because the language was designed in a different way. So, to try to answer the question, no, it is not planned, and I think it would be very hard to implement, because also due to the way union types work, like an object in Crystal does not have an interface, so it cannot precisely reference a particular offset in a vtable. That is calculated on a case-by-case basis.
On each call site.
Yeah, on each call site, on the union types, on the types that particular variable can have at that point. So I think it's pretty impossible, or maybe it is, I don't know. But right now I can't think of a implementable way of doing that.
Yeah, and the initial design was to have better performance, and that was the idea of dispatching the method like that. although it might seem like a lot of code when you have like a big union and there is a case somewhere that performs the dispatch. But it's working, like it's giving us awesome benchmarks all over. But well, things might change, but as we said, the representation of the object are pretty small, and how the code gen is the idea is to be as efficient as possible. Okay, that's it.
Yeah.
Next.
Yeah.
Next question. What do you expect Crystal's killer app niche domains to be? What work do you need from the community to get there? This question was from Doug Everly. So, well, the first niche, I will say that Crystal is good for writing compilers. But joke beside, I like to.
So we're good at benchmarks also.
Yeah, we are really good at benchmark, definitely. Microservices are always tempting because we have like some way to expose an HTTP server. We can even deploy it using small Docker images. We can interact with different databases already, write JSON, stream JSON without a huge memory footprint. So that's great. We have WebSockets, and that's
one binary deployment.
One binary deployment is great for microservices.
All the production uses I'm aware of are actually microservices.
Yeah, they all start from there. Another great use, I think, are command line tools, because once you compile them, they will run really fast. You won't need to load and parse a lot of files each time you want to run a command. That's pretty annoying because the command lines needs to be fast. That's why we want to have a faster Crystal compiler also. Otherwise, we'll put an IDE with graphics, and you will need to have patience for that. For it. But so I would say that microservices and command line tools are the two first things that will appear. But I'm not sure if there is some kind of limitation. It will depend on the frameworks and the community where it goes. Some time ago, we had this experiment for doing native Mac applications. And we know it's possible. We know it's possible to create a zip file in Xcode and define classes that will be that will live in Objective-C runtime, and you can code it in Crystal. It was an experiment, and it was okay, and it's doable, but it's not the things that will sell Crystal more. We have bindings to graphical interface, although they have their challenges with managing the event loop and the garbage collector. But since it's bindable, it's doable. And then maybe one of the other questions is like a full web application is doable. It is doable. There are frameworks are getting bigger and better. Faster. We need to make something with that. But the ecosystem needs to still grow. But
I think probably the most the first limitation, or the current limitation of Crystal, is the compiling times and compiler size, compiler memory footprint themselves, because Crystal itself, to compile the compiler, it uses about 2 gigs of RAM, more or less 4 gigs, and it takes a long time. And Crystal, the Crystal compiler itself is about 50,000 lines of code, which is not that many lines of code from very enterprise-like application point of view. So once we improve that aspect of the compiler, maybe we can adventure into new lands and try to make experiments. Explore new niches and new types of applications. But until that is solved,
and before that, there's like the efforts with parallelism. Once that's done, maybe something like higher level abstractions like actors or something like that. That's all before delving into a web framework.
We're running out of time, so
let's finish the question. Like, what is the work needed for support? No, but the concrete in the code, we want to refactor for better platform support that will allow us to move to handle more scenarios. But also, if we compare Crystal with other languages and other frameworks, we don't have some toolings are needed. It's not about just compiling the code and make it work. In order to convince someone to deploy a servicing a system in Crystal, you need, for example, to have a monitoring on that. And it's not just like the computer doesn't explode. We need to maybe be able to instrument a little bit the code and maybe explicitly like measure like this is the action of the handled by the Kamal framework, and it's taking this time or not, or some much time in the database. Like when the thing that you can do in New Relic with Rails, which just including the gem, like something around those lines will help compare how it performs on production.
Yeah, and also just picking an interesting use case and trying to do something real with it that sources real limitations or real things that you would like to have further. I mean, beyond the hypothetical, would it be nice to have like indentation-based or significant space syntax, which is more.
For example, some time ago there was a post from Mike Perham regarding how to use the profiling tools in Xcode for a Crystal program, and it was doable. And for example, I would love to see like go down the rabbit hole how to analyze the code coverage of code running the specs. Like, and how it can get into the either reporting or highlighting in the editor, like which lines were covered or not, using all the debugger information that the program has still. Like, that is something really great because it's help to offer more support for the enterprise development story. But then, like, in the language, we still need to discover like the best practices, the patterns that will arrive from this language that is different from others. Like it's different from Ruby, different from C, and it will have its own patterns and best practices. So learning the languages and helping to teach the language and helping support is something really great because like
that's already happening.
That's already happening. Yeah. But that's a really great support. If you go and answer and give support on GitHub, it helps things to move forward. Okay, there are like three more questions.
Yeah, what the first one is from Faustino also. What services at Manas Tech are using Crystal? Well, we have our internal systems and internal management system. And it's a small system that controls finances and
availability of
the team and all that sort of things. It's obviously an ad hoc system we made.
Yeah, it's like a microservice with a web interface.
Yeah,
Connected to Slack.
It generates the invoice for our clients, for example.
Yeah.
I've used it for
For
you know,
bots, right?
a lot of for example, we generally work a lot with GIS systems, and we need to process shape files or biggish JSON objects that represent geo features. So when I have to do a lot of crunching in a script, sort of to prepare some data to be readily available for bigger applications, I use it a lot for that also.
Yeah. So we have been doing bots in Slack or Twilio or other services. Okay, next question was, there are about a dozen web frameworks built on Crystal already. Which ones have the most traction? By Joe Seeley? Yeah, Joe. I don't know.
Yeah. Obviously, Kemal leads the way there.
There's Kemalist also.
Yeah.
And
Frank is there.
Which one?
Frank, before the one that we developed, but then they are being developed by people in the community. There was Mustafa and NBC also. There are a lot, but yeah, definitely Kemal has the most traction, and they're evolving and trying to have their own, discover the best patterns for making web frameworks and database mappers for your models. The community is like which ones that has the most traction. We don't have a vote there actually.
Yeah, absolutely. Last question.
Yeah, sorry. Before going on the next one, Santiago Paladino is here on the chat reminding us to don't forget about the chatbot we built for the United Nations that was done in Crystal. Well, it's going to be used in production in mid-June, so that's a chatbot. I don't know. Well, you can read him here, but it's working. So and that was our first Crystal development for a client, for managed client. That was you can tell that besides all we love programming, we love to build programming language and all that stuff. One of the many goals that Crystal have is, okay, we want to build a programming language in which we can enjoy doing our work, and so having our first job for a client done in Crystal is like one of our
and also to have a greener world, right? By saving resources, less computers, and
okay. Last question. Why did you choose Crystal as name and an icosahedron as logo?
Crystal is just a derivative
of Ruby. But also it has the C in the name.
It has a C in the name, and it was more transparent in a way than a Ruby. So
more lighter. Initially the name was Joy, but then after 1 month it's changed to Crystal. I think that we also searched, like, the CR extension wasn't that used. And the icosahedron, well, actually it was supposed to have one different shape on every release, which is kind of hard for the marketing and all the mags that we are trying to give away. So we stick for the icosahedron because, I don't know, the designer.
Absolutely.
It's pretty, and we can build it out of paper and that stuff. So it's it kind of
and it works. Yeah, the designment apartment made that decision. But yeah, initially were a lot of like shapes that it was going to evolve from version number, but we dropped that and we stick with this nice logo.
I think the color was also going to change, right? From version to version.
Everything's going to change. Nothing is fixed. Okay, we are out of question and we are reaching the 1 hour.
Yeah, 1 hour mark. So it's 10 p.m. here in Argentina, so it's quite late for us also.
We are not going to ask Serdar which time it is.
Yeah,
because we don't want to know.
know.
Sorry, I hope you're sleeping right now and not here on the chat.
Absolutely.
But thank you for being here if you are.
Yeah, definitely. Thank you all for coming, for joining, for posting those questions. And well, if anything is we didn't answer, or well, there's the Gitter channel, the IRC, there's the mailing list. You can always send new questions, and we can find.
Yeah, we are Rachel. We just wanted to show our face and our like that we are humans on the other side. So express what some of our thoughts that are not visible in the repositories and and help things move forward. So maybe see you next time, or on Twitter and GitHub.
And remember bounty source.
And remember bounty source.
Yes,
yeah,
of course.
Always remember bounty source. Seriously. Well, no, seriously. Thank you for your time, and well, see you around.
Yep.
See you.